Okay, hi class. So we're doing the last section in chapter 1, inverse functions. And here we're going to be, I don't want that right now. Here we're going to be just kind of introducing the topic of what an inverse function means. And again, hopefully it's a little bit of review. And then we're going to be talking about the domain and range. So we'll hit that again. And then the last thing is we'll identify one-to-one functions. And we talked a little bit about that last time. Remember, one-to-one means that it passes the horizontal line test. And domain and range we're going to bring up again. So if you're a little rusty on that, make sure you go back and refresh yourself on that first, okay? Okay, so let's talk about what an inverse function means. So an inverse means that if you say I give you a function like I don't know, f of x is equal to x squared. Actually, let's do the opposite first. Say I give you square root x. Now, what this does to an input is it takes it in and it takes the square root of it. So if I plug in 4, I'm going to get 2 coming out because square root of 4 is 2. But if so that's f of x. Now, if I want to come up with something that will undo that, so if I plug in 4, so f of 4 is square root of 4, which is 2. What an inverse function is that it's some function that, okay, take this 2 and then somehow get back to 4. And I think, so an inverse function is something that will kind of undo what your function did to a number. And so you can kind of see already what is the inverse, the thing that undoes a square root. Well, if I just plugged a little 2 power right there, if I square that, so if I square the function here, then that's going to square 2, and that's going to give me back to 4. And that is kind of the goal. An inverse function, let me undo that. An inverse function kind of undoes whatever your first function did, and it gives you back to that input. So that's what it kind of means in symbols, is that if you take a function and you do an inverse first and then you do a function, what it does is it undoes kind of each other, and you're left with just whatever you started with, the input. And it's the same way over here. You know, if I square something and then square root it, so if I kind of did this in reverse, I should still get a 4 coming out. And so it's the same thing here. Okay? So f and f inverse, that's the notation for an inverse, always undo each other. Undo each other. And what you're left with is not the number, is what you're left with is x, is the input. Okay? Same thing here. Now, people usually get kind of confused. F inverse, we've been using this symbol in like algebra 1 and algebra 2 as the reciprocal. So, if you saw like, x to the negative 1, you kind of know that that's also the same thing as 1 over x. Unfortunately, it doesn't mean the same thing here. So when you have let me make sure I'm recording. Okay, when you have minimize that. When you have this notation, it doesn't mean that. It does not mean 1 over f of x. Okay, so inverse does not mean reciprocal. So just be careful. Okay, this symbol f with a negative 1 power actually just means the inverse. It does not mean flip it. It does not mean reciprocal. Okay. So just to help you out, it's really, the idea of an inverse is pretty simple. Like, we can look at a lot of these kind of simple functions like 2x and just ask ourselves, okay, what is this inverse? Because remember, what an inverse does is that it just undoes whatever the first function does. So if f always multiplies everything by 2, what's the thing that's going to undo multiplying by 2? Well, it has to be division by 2. So x over 2 is going to have to be its inverse for that one. And same thing here. If I always divide everything by 3, what's the thing that's going to undo dividing by 3? Well, it's going to be multiplying by 3. And we did this up at the top of the page. If I square root something, what's the thing that undoes that? Well, it's just taking that value and squaring it. Okay? And this is just a quick refresher. If I cube something, the way we undo a cube is we take the cube root. Okay? Or, just a reminder, algebraically, that's x to the 1/3. So, if that is totally new to you, that cube root writing as a 1/3, okay, we're going to be using that a lot this semester, and so that's called rational exponents. So, if you have never seen that before, just relook at that. Look this up just real quick. It's just to get your practice. Rational exponents are another way to write something like that. Now, what about, is there something that will undo an absolute value? And, well, absolute value gives you a positive number. It gives you the distance away from the origin. Now, the problem is actually there is no inverse for this one. And why is that? Well, the problem is that if I put in a number like, say, the number -3, so say f of -3 is equal to the absolute value of -3, well, that's equal to 3. How can I get back to -3? Well, you might think, okay, let's multiply by -3. It looks like absolute value kind of takes away the negative, so let's put the negative back on. And so you might think, okay, well, the inverse would just be -x. But the problem is what if I plug in +3? So if I plug in, so let me erase this. If I plug in +3, I get the absolute value of 3, which is 3. And if I multiply that by a negative sign, that does not get me back to where I started with. And so this is not a good inverse. And it turns out there's no inverse. And we'll find out why. It's pretty easy to tell on a graph. But this does not have an inverse. And really quickly, the easy way to tell if something has an inverse, I'm kind of, spoiler alert, getting to later on, but it does not have an inverse if it's not 1-to-1. And so the graph of absolute value of x is not 1-to-1. It fails the horizontal line test. And so what that means is that, there's not an inverse, so not invertible. Anyways, that's the quick and easy way to do it with the graph. We're going to cover more in this section, so let's move on. Okay, so let's take a look at this problem. This says that we have a 1-to-1 function, and it has these inputs and outputs. Another way to think about inverses is that they kind of swap the x's and the y's. So for instance, if it tells me that f of 2 is 4, so that means over here I have this coordinate pair, 2, 4, and it also says I have 5, 12. Remember, that's an x value, that's a y value. That's an x value, that's a y value. And so what inverses do is they kind of swap the, let me write that. Inverses swap inputs and outputs. Inputs and outputs. So that's kind of nice algebraically. So when we have a function and it has its inverse, all that its inverse does is that it just literally just flips these so that the new coordinate pair would be 4, 2, and this one will be 12, 5. So that's real important. Maybe this example wasn't the best at explaining that, but this concept of inverses, what they do is they swap inputs and outputs. We're going to be using that a lot. And so just a little introduction for you here, but that concept is really important. So let me write this important. And we'll see that more as we move on. So let's go ahead and move on. And now the question is, how do we tell if two functions are inverses? So, we want a quick and easy way to tell. Well, remember, the way you tell is right up here. If we do this composition, then they should cancel out, and we should just get x. And so that's how we tell. If I just give you two functions, the way you tell is okay, go ahead, compose them, and just see, okay, do you get x out? And it doesn't matter which way you do it. If you do f of g or g of f, it doesn't really matter. So you only have to do it once. And you have to show one or the other. So let's go ahead and let's take a look. So if I have these two functions, I don't know anything about them. I'm not going to graph them or anything. I just want to know, okay, just from the algebra, can I tell if they're inverses or not? And what you do is you just say, okay, well, let's check. Let's do either f of g of x, and if they are, then they should just cancel out, and we should just get x. We could also do g of f of x equals x. Either way, it doesn't really matter which one you do. I'll just do f of g of x, and let's see what we get. So this composition, remember, that's going to be 1 over, let me write it again here, just to make it really clear, f of g of x, that's going to be f of, what does g of x do? It produces this thing, 1 over x minus 2. So we're going to have 1 over x, take away 2. And then what does f do? Well, it takes its input, and where does it go? It goes right into here, just to that bottom of that fraction. So for us, we're going to get 1 over x minus 2 plus 2. Okay? Just to be clear, this went right into there, into that input, and that's all. And then we still have the plus 2, and this is still all underneath the 1, a fraction. Okay? Now hopefully you can see what cancels out really quickly is the negative 2 and the plus 2. And so now we're over to this, 1 over x. Okay? And, remember how this works. If I have a fraction with a fraction, this comes up and becomes a reciprocal, so we get 1 times x over 1. Little times symbol there, and that's equal to x. So yes, f and g are inverses. Sorry, my handwriting is not good. Okay? And we can do it the other way, g of f of x. I'll leave that to you to practice, okay? But if you do it the other way, you should get the same thing. This should be a yes, okay? So let's go ahead and do the next one real quick. I recommend try practicing this one first, and see if you can see if they are inverses or not. And then come back, go ahead and pause the video, come back, and you'll see if your answer is same as mine. Okay, we're back, and the answer is definitely it's a big no. Let me go back here. The answer is a big no. Okay, and the reason is that if you do f of g of x, say, that would be f of 1/3 x, which would be, remember what f does, it takes this input and it cubes it, so we get 1/3 x cubed which is equal to 1 over 27 x cubed. Okay, and that is not x. So f and g are not inverses. Okay, hopefully you practiced that on your own and got the same answer. Okay, and if you did g of f of x, you're going to get something a little different. You're not going to get 1 over 27 x cubed. If you did g of f of x, just quickly, I won't show the work, but that's going to be 1/3 x cubed. This does not have to be the same as this, okay? But all I know is that they're not equal to x, and so because they're not equal to x, they didn't cancel each other out, so they're not inverses. Okay, all right. So now that we know that, kind of how to check that, a little more concept for everyone is that remember what an inverses undo each other. So what that means is that basically they just swap domains and ranges. So if I take a look at kind of a graph of f and I look at the domain of f, okay, that is exactly the same thing as the range of its inverse, okay, and vice versa. The range of f becomes the domain of f inverse. So inverses swap domains and ranges. Let's get a concrete example here. So if I have this function here, domain of this function is 1 to 1, so the domain of f is 1 to infinity. Okay, so x can be anything between 1 to infinity, not including. And the range of f is negative infinity to negative 2. Its inverse is going to have the exact opposite. So for its inverse, the domain of f inverse, and let me erase this real quick. The domain of its inverse and is going to be the exact opposite. So range of f inverse, they just get flipped. So this will be negative infinity to negative 2, and this will be 1 to infinity. So just remember that inverses swap everything and you'll be okay. Okay. All right. So for instance, let me kind of do that problem again. So for instance, this function has an inverse. So the domain of this graph is, let's say of f, looks like it's, let me just kind of stop it here, so it just stops here and here. Then its domain would be negative 1, put a little bracket. Well, this example isn't very helpful. Let's just move on. So we're going to skip this. I don't think this is that important, so we can just skip that. And we're going to move on down to this problem down here. I think we need kind of a visual help here. So let's just take a look at this visually. So here we have a graph. I'll let you read the problem. And we're just going to find these two values, g of 3. Okay. So number 1, g of 3. Okay, g of 3, what does that mean? Well, we take a look at this example. 3, okay, this graph is g, so this is g of x. And so 3 here is going to be the input. So we go here, we find x equals 3 right here first. And g of 3 means, okay, go up to your function. And what's the output? So here, g of 3 is the output right there, which is 1. Okay, so g of 3 is just equal to 1. It's the y value when x is 3. Okay, pretty straightforward, but this one's asking us a little bit different. It says, okay, now find the inverse of g at 3. Now, I don't have the inverse. I don't know what the graph looks like. But the cool thing is that I don't need to know what the inverse looks like, because all I know is that, again, I know that inverses swap domains and ranges. That also means that they swap, inputs and outputs. So what this is really asking us for is g inverse of 3 really is asking us for, okay, this 3 here is not going to be an input. It's not going to be an x value. That's going to be a y value. So this is asking us, okay, this is telling us y is equal to 3. And then it's asking us to find the x value. So when I read these problems, when I have an original function, like on this problem, this 3 was an x. Okay? But this g inverse, this is actually going to be a y. And so I look at, okay, well, let me erase this stuff here. And if I look at, okay, here's 3, I want the inverse of that. I want the x value that makes that so. So I go over here, and then I go down, and it looks like 5. And so that's going to be 5. And just to explain again what that means, kind of algebraically, this is because if I did g of 5, the original function, I got 3. And if I take in an inverse on both sides, inverse, inverse, g inverse of 3 is really just asking us for, okay, find the inverse of g of 5. But we know something really cool about inverses is that they cancel each other out. So g inverse of g just cancels out, and that is why we got the answer that we did, which is g inverse of 3 is just equal to 5. So kind of cool. You can do it algebraically, and you can also just kind of do it visually. I like to do a visual because I'm kind of a visual person. So I looked at the graph, and I saw 3, and I know that this 3 is an output, and so I just looked for the output first. And then I went down and found the x value. Okay. So hopefully that helps a little bit. I asked some questions on the homework too that will kind of help you clear up, and make sure you use the tutorials as well. It's kind of a little bit of abstract because we don't have functions, we don't have pictures all the time to deal with. So it is important, especially throughout the semester, to kind of understand the concepts as well as being able to do any algebra that we need to do. This problem we're going to actually, for the rest of the section, we're just going to be applying our algebra skills, okay? So the way we're going to do that is we're going to tackle this problem, which is how do you actually find an inverse? We haven't found an inverse yet. So the way you, algebraically I should say, the way you do it algebraically is, say I gave you a function like on this problem right here. How do you do it? Well, the way you do it is that it's pretty cool. What you do is you actually just solve for x, and then you change the variables. Let me show you an example. So for this one, what you do is you just say, okay, I'm just going to number 1. Let me do it over here. I'm going to solve for x. So number 1, solve for x. Okay. All right, so right now I have y equals 2 over x minus 3 plus 4. Remember, f of x is a synonym for y, so when I had f of x equals, it's the same thing as y equals. And the way I solve it, okay, is I subtract 4, subtract 4. And what we get, okay, next line, we get y minus 4 is equal to 2 over x minus 3. Okay. Now you might think, how the heck am I going to solve for that x minus 3? Well, what you do is you just multiply, you clear the denominator. So I'm going to do that over here too. And now we're going to have, all of this is going to equal 2, because these denominators cleared out. I need to actually solve for x, so I'm actually going to, I'm not going to FOIL this, so I'm just going to get x minus 3 times y minus 4. Okay. And then I'm just going to go ahead and, just from this step, I'm not going to multiply or anything, I'm just going to divide here. Those cancel. Okay, and then I'm up over here, and then I get x minus 3 is equal to 2 over y minus 4. And last step, I promise, is that if you add 3, then what we get is we get x is equal to 2 over y minus 4 plus 3. Okay, and a little happy dance, that's almost done, except the last little step is that, number 3 is you just go ahead and just swap out x and y. So the last step to actually get our inverse is that y is equal to 2 over x minus 4 plus 3. Okay, and so I'll summarize that up here. So f inverse of x for us on this problem is equal to 2 over x minus 4 plus 3. Okay, so that is how we find an inverse. We try to solve for x first, and then once we've solved for x all the way down to here, last step is just go ahead and swap the x and y variables. Why can we do that? Well, remember that that's what inverses do. They swap inputs and outputs. So they swap x's and y's. And so that's why we get y equals to 2 over x minus 4 plus 3. Some of you might have learned it a little bit differently, which is you might change these steps. You might swap x and y first, and then you solve for y. That's completely fine. I don't really care either way, because it turns out that mathematically you get the same answer. So if you first want to swap x and y and then solve for y, you will get the exact answer every single time, no matter what. And so let me pause the video. I'm going to do it the opposite way real quick. Actually, I can just do it here. So you can do it the other way, which is you can swap x and y first. And you'll see that you're going to get the exact same answer. And if you don't really care about doing it a different way, that's fine. You can skip over this part of the video. No problem. But I just want to show you that you can do it either way, and you're going to get the answer. So if I do it that way, I'm going to do it a little bit quicker. I'm going to swap y and x first. So this tells me just, y is equal to 2 over x minus 3 plus 4. If I go ahead and then immediately swap them, I get x is equal to 2 over y minus 3 plus 4. Okay? Then all you do is you just start solving. You want to solve for y now. And you get x minus 4 is equal to 2 divided by y minus 3. Okay, and then you just clear the denominator. You multiply this side by y minus 3 as well. Okay, and then you go over here and you get y minus 3 times x minus 4 is equal to 2. And again, you're trying to solve for y here. It's a little bit different. You're trying to solve for y, so you can just divide by x minus 4. And you get y minus 3 is equal to 2 over x minus 4. Okay, and then last step, again, we're trying to solve for y here, so you add 3. And so your final answer is, guess what? The exact same thing that we got doing it the other way. So either way, I don't really care. If you want to swap x and y at the first step, just remember that you then try to solve for y. Or if you want to do it the other way, solve for x and then swap y and x, no problem. Either way, you're going to get the same answer every time. Okay. And the last thing we want to do is let's get practice finding an inverse again. And then we're going to be talking about the domains real quick, and then that'll be it. So if we take a look at this problem here, we will have a function right here. The first thing it wants us to do is find the inverse. So let's get practice again. We'll do that over here. Okay, f inverse. The way you do that is either way, solve for x and then swap, or swap first and then solve for y. I'm going to solve for x and then swap, so you get, so this is y equals to, let me erase this so you don't think I'm saying what that. So let's find f inverse. So we have y is equal to 2 plus root x minus 4. I'm going to swap x and y real quick, so I'll get x is equal to 2 plus root y minus 4. And then what do? Well, I got to solve for y, and so subtract 2, and you get x minus 2 is equal to square root y minus 4. And then again, I want to solve for y, so I'm going to square both sides. Okay. And okay, so I'm doing this way the second way, which is, I swapped x and y, and that's fine. Okay, swap x and y, and then you try to solve for y. The cool thing about squares and square roots is they cancel each other out, but remember I have to do it to the other side. So square. And so now I have x minus 2 squared is equal to, the square cancels out with the square root, so I'm left with y minus 4. And so then the last step is I just got to add 4 to both sides. And I get x minus 2 squared plus 4. That did not look good. Okay. And so that's f inverse. So f inverse is equal to x minus 2 squared plus 4. Okay? All right. So what that means is that we found our inverse, and let's go ahead and find the domains of each as well, and it might help to graph it too, so let me graph it real quick down here. If you, oops, let me get back to pens here. Nope, no. Okay, go to pens. All right, so if you graph the original function, we had a square root 2 plus square root of x minus 4. Okay, that's going to look like this. It's going to be moved. It's a square root, which looks like this. It's going to be moved. So was it plus 4, minus 4? Okay, so it's going to move 4 units to the right. 1, 2, 3, 4. And it's going to be plus 2. So plus 2. So it's going to look like this. Okay, and so that's the original graph. Wow, Microsoft Word doesn't like me. Okay, so that's the original graph. So that's f of x equals 2 plus the square root of x minus 4. Okay, what this graph looks like is it looks very similar, except it's going to be swapped across the line y equals x. So the way inverses look is that, like I said, I've been saying kind of for this section, is that they swap inputs and outputs. So what this graph will look like is that it will be swapped across here. Excuse me. Okay. So that means this graph starts at 4, 2. That means our graph's can start at 2, 4. So right here, like that. Okay. And it's going to look like a parabola after that. So it's going to look like this. Okay. So this is f inverse. Okay. And that helps me because now I know what the domain of f is. The domain of f, it was a square root function. It couldn't start before 4. So it starts at 4 and goes to infinity. Okay. And the range, it looks like it goes from the lowest it goes is 2 to infinity. Okay. Now I know the domain of f inverse has to be the range of f. So just remember that inverses, what do? They swap inputs and outputs. So the range of the first function has to become the domain of the second function, which is going to be 2 to infinity. Okay? Now this is important because our graph right here, our function that we found, x minus 2 squared plus 4, it actually has two parts. It has this part of the parabola. It also has this part of the parabola. Okay? But you have to be careful. We're not allowed to put that there because and I got rid of my axes right here, because of this domain issue. So that's why this graph here the inverse can only include this part. Okay, that's it for that one. So I'll post the notes and go ahead and start working on the homework. And if you have any questions, make sure to message me on Canvas and start the homework. And they have some tutorials extra that I want you to look at on these problems to help you. Okay, and that's it. That's actually the end of chapter 1. So I'll see you next time, starting chapter 2. All right, thanks. Bye.